Alrighty, well today we are going to finish solving radical equations notes. It's not going to take us very long, just like yesterday, it's not going to take us very long. I was actually hoping that some of you would have already started the homework so you could ask me some homework questions today. Please do me a huge favor, try to do the homework tonight because tomorrow is a practice day. It's not due tomorrow, tomorrow's a practice day, and I would love for you to be able to come in and already have questions in mind. That way you can see when they get answered during the practice, or if they don't, you can ask me to address them. That's the whole point behind the practice days and giving you the extra time on the homework. It gives you the opportunity to see where you are stumped so you can get help on those things. That's what I want to do for you. All right. Now, yesterday we focused on solving even roots, square roots, and I think eventually we ended up with a fourth root, yeah? Yeah, eventually we were dealing with a fourth root kind of situation over here. This is technically a fourth root. Today we're going to focus on the odd roots. So why bother separating them? Well, the reason why is because when you're dealing with even root things, you can run into imaginary numbers if you're not careful, aka extraneous solutions. Remember, with even root things, you need to always check your answers to make sure they actually work. Because sometimes the radicals lie. When you cancel them with algebra, you got rid of your restrictions, and that's why you can end up with extraneous solutions. The gorgeous thing about odd roots are they have no restrictions. You can plug in anything you want. You cannot get an imaginary number with odd roots. So they're actually easier to work with, which is a nice thing. Let's dive right into it. We are still following the order of operations in reverse, SAD MEP. The first thing we're going to do here then will be what? Yeah, it's going to add. It's going to get rid of that -1. Let's add 1 to both sides. I'm left with a cube root of 2x minus 9 equals 3. Clearly, in order for me to get to that x, I'm going to have to do something with this radical. So how am I going to cancel a third root? I need to cancel the root. What cancels roots? Over here, look, we canceled this square root with a squared power. So we're going to cancel a cube root with a cube power, a third root with a third power. So you raise both sides to the third power. That leaves us with 2x minus 9 equals 27. Algebra 1 now. Get x by itself. Following PEMDAS in reverse order, we're going to add that 9. Give me 2x equals 36. And then divide by 2. Now, because cube roots can never give you an extraneous solution, the only reason why you would check your answer is just to make sure that your answer is correct. Not because you're worried about getting something extraneous. I mean, it's not too much work, though, to take that 18 up there and see what's up. Let's see. 2 times 18 is 36. 36 minus 9 is 27. The cube root of 27 is 3. 3 minus 1 is 2. Good, it's correct. But I was only checking just to make sure my answer was right. Not because I was worried about it being extraneous. Not possible with cube roots. Now, it seemed like we were having some trouble telling me what would cancel a third root. I want to remind you guys that roots, radicals, are exponents. They are fractional exponents. So this cube root, this third root, was the 1/3 power. In order to cancel an exponent, you raise both sides to the reciprocal exponent. Since this is technically a 1/3 power, we had to raise it to its reciprocal third power on both sides. That's the plan. All right. Now down here, if you recall to yesterday, right here, we said what we couldn't do was square this side. And I demonstrated that with you with numbers. I think I did the square root of 25 minus the square root of 9. And I demonstrated that you can't just square to make these radicals go away. What was preventing you from doing that was this minus sign. And it would have been the same thing if it was a plus. It still would have prevented you from doing that. The move was get the radicals to their own sides of the equation, because then I could square both sides. And that would crush both square roots. So what do you think we're going to do here? Yeah, same exact attack. Get the radicals on opposite sides of the equal sign. So you're going to add 2 cube root of x minus 4 to both sides. That is going to leave me the cube root of 2x plus 5 equals 2 cube root of x minus 4. What do you think we're going to do, folks? Cancel the what? The cube. Cube root, you mean. We're going to cancel the radicals. This radical is alone. That means I can cancel it. Cancel third roots with third powers. So we raise both sides, the entire side, to the third power. That means I'm affecting this too as well. Like that. So what's happening here is that algebra 1 concept that we talked about when we said that when you have more than one thing inside the parentheses that are separated by multiplication, that everything in that set of parentheses gets this exponent. We apply this exponent to all the objects inside that are separated by multiplication dots. We apply this third power to this third root and to this 2, not just the third root. On the left side, the third root and third power just cancel each other out. On the right side, yeah, I am going to crush this root with this power. But I don't want to cross this little 3 off, because I'm afraid that it'll make you think that I didn't need it on the 2. I'm going to show one more step to make sure that we don't run into that issue. And that step says this: 2 to the third and cube root of x minus 4 to the third. See, I gave that third power to both objects. Now I'll cross it off, because I don't think we'll mess it up now. Like that. You all comfortable with why I did that? All right. 2x plus 5 equals, well, 2 to the third power is 8. Be careful. You see how there's a set of parentheses around this radical? There's still a set of parentheses there. Extremely common student mistake. Don't write the parentheses and just write 8x minus 4. It's going to get you if you do that. Please don't do that on the test. I'm warning you right now. If you're one of the people that's done all your homework, go ahead and write yourself a note, because you're going to be using your notes on your test. Watch out for this. He's telling me it happens on the test. Do not write 8x minus 4. No, you must distribute the 8 to the x and the minus 4. So you just get everything to all your x's to one side and all your numbers to the other. Got a question for me, Nick? What's up?
So whenever you multiply both of them by 3,
Yeah.
Your root got canceled.
Yes.
It's going to make it cancel on the right because you have a number in front of it.
Yeah. So when I raised both sides of third power, the goal was to cancel the third roots, right? But the problem was inside this set of parentheses, there were two different objects that were getting this exponent. And I was afraid if I went ahead and canceled them right here, that you would forget that this 2 also needs this exponent because it would have had a line through it. So I took one more step and I wrote it out saying, look, they both have the exponent. Now we'll cancel that radical. It was just a precautionary move to make sure that we didn't forget that the 2 also needed the exponent. Alrighty, I like my x's to be positive, so I'm going to subtract 2x from both sides. And at the same time, in a different color, I'll move my non-x's to the left. What do I end up with? I end up with 37 equals 6x. Okay. Just divide both sides by 6 and you're finished. X equals 37 over 6. Mr. M, I got an ugly answer. I must be wrong. No. It's a fraction, so what? They happen all the time. It's not a big deal. Don't assume that every answer is going to be pretty. Mr. M, you just said that we want to be checking our answers. How the heck am I supposed to check something like that? Ah, lucky for you, it's a cube root question. It's impossible that answer is extraneous. Okay? So you don't have to check it. I wouldn't give you an answer like this in a square root question and then tell you, oh, by the way, make sure you plug that bad boy in and make sure it works. I'm like, oh my gosh, 37 over 6? I'm not going to do that to you. But just because you get a fraction answer doesn't make you wrong. For some reason, students think that all answers are pretty. No, most answers are not. There's a lot more decimals in our number system than there are whole numbers. Any other things I can clear up about that question, or is it pretty straightforward stuff? Pretty straightforward, right? Oh, guess what? We're ahead of some of the other Algebra 2 classes now, including the honors kids. Because we skipped the end of Chapter 3 and the end of Chapter 4, we caught up, because we were dead last on campus. We caught up. Ms. Bluebaum said that her students are being killed by the fraction exponents and reducing radicals. She said they can't figure it out. She said she spent over a week reducing radicals with them, and they still can't do it properly. So, I'm just saying, let's make them feel dumb. Okay? You got to help me, though. I can't do it myself. Test is Wednesday of next week. I was like, oh, really? Yeah, mine are doing fine with that. Don't make me a liar. Okay? All right. Fraction exponent, speaking of the devil, let's make it happen. What would you do first? Add 4. Let's add 4 to both sides. Trying to peel this onion. Sad mep. What would we do now? Come on, more than Lewis knows this answer. Come on, guys. Don't make me pick victims. It's not nice. I want to do it. You would divide, yeah. I'm not telling Lewis not to talk to me. I'm just saying more people need to. It can't just be him. You don't learn how to do things by watching. You learn how to do things by doing and making mistakes. Could you imagine if your doctors learned how to do surgery by watching other people do it? Yeah, of course we learn by making mistakes. Sometimes it does. Sometimes doctors kill people. Not on purpose. But it happens.
That's the better way to learn?
By making mistakes? No, by making mistakes. Gotta learn. We have to make mistakes. You have to.
Oh, yeah, no.
Gotta make mistakes. Can't be afraid to make mistakes either. Otherwise, no one would ever get married. All right, well, so what do we do here? Tell you what, rather than raising both sides to a reciprocal power, which is what we did yesterday, why don't we tackle it the way that Lewis and I discussed yesterday? I don't know if you guys remember. How about I make it a radical now? And then we'll just cancel it in 2 moves. How's that feel? Let's do that. Because I get the feeling, and I'll be real with you, Lewis, I did it that way with third period yesterday. Because I get the feeling that doing it that way will produce less mistakes from the students. Maybe it's a little more work, but it's going to produce less mistakes. So I'm going to transform my 2/3 power into a radical right now with an exponent. The 3 on the bottom tells me I'm dealing with a cube root. So I have a cube root of x. Now I could put that exponent here, or I could put that exponent here. It will not matter when you do it. The 2, I could put it here, I could put it here. It does not matter when you do it. Completely up to you. But, if you put the 2 right here, let's just say, I'm going to do it in pencil, nobody write this, okay? If you put the 2 right here, because we're going to have a 9 over here, what would be the move? What would you do from here? Well, this is inside the radical. You would have to cancel this. How do we cancel a 3rd root? Come on, guys. How do we cancel roots? Powers. So I would have canceled this root 3 with a power of 3, right? How many have memorized that 9 to the 3rd power is 729? None, right? So don't do that. That number's big, and I haven't asked you to memorize it. So instead, so you want to think ahead a little bit. Instead, since that number is going to be so large, and since your next test is a no calculator test, the move is put that 2 out here. Now, this is the outside-most structure. Since we're peeling the onion, this is the one we handle first. How do we cancel a square? But what is the reciprocal power of 2? 1/2, which is the square root. We cancel squares with square roots. Right, guys? That's old material. Here is me canceling a square with a square root. When you cancel a square with a square root, you get a plus or minus situation. Because I canceled an even power with an even root in that order, I canceled an even power. Canceling an even power will create this plus or minus situation. If this was a 4 and I was canceling it with a 4th root, it would still be a plus or minus, yes. Anytime you cancel an even power, you have created a plus or minus. Because raising negative numbers to even powers is the same as raising positive numbers to even powers. You get the same result. So we actually didn't know, because here's the thing. Inside here, cube root of number can be negative, can't it? The cube root of this x could have been negative, or it could have been positive, and since we didn't know which one it was, we have to assume that it was both. Yeah? Oh, you weren't raising a hand. You were okay. So here we have the square root of 9, which is 3. And over here, I still have a cube root of x. I have x by itself. When I cancel that cube root, how am I going to cancel my cube root? Okay, Catherine and Lewis are talking to me. 3rd power. X on the left side, plus or minus, and what's 3 to the 3rd power? 27. So positive and negative 27 are our answers. Now let's compare those questions. The one we did yesterday with the one we just did. Let's go all the way back to the original. This exponent did not require a plus or minus at the end. This exponent did. There's a fundamental difference between the two. So those of you that have open note tests are going to want to write this down. Those of you that don't, why? Anyway, there's a fundamental difference between this exponent and this exponent. This one that didn't require a plus or minus, this one that did require a plus or minus. Would anybody like to take an educated guess, because I haven't taught you this, at what's causing this difference? Ohm, give it a shot, dude. Worst case scenario is you're wrong.
Is it because there's a plus sign on the left and a minus on the right?
That is definitely a difference. And I'm glad that you said something. But it's not because of that plus here and minus here. I will tell you, it's something to do with the exponent. So this exponent, which is a 3 over a 4, and this exponent that's a 2 over 3, something about this exponent caused the plus or minus that did not cause the plus or minus with this exponent. Again, I haven't taught you guys this, so if you don't get it right, okay, so what? I'm just asking you to think about it. Catherine, give it a shot. What do you think? The parentheses here could have been done over here as well. So it's not because of the parentheses, but hold on to your thought for a second. Because yesterday with Lewis, I did say, well, let's do this with the fourth root of 2x to the third. And I said, you know, you will eventually have to do this stuff to both sides so you get the same answer. So the fact that I chose to do radicals first over here actually didn't cause it, because I could have done radicals first over here. But the radical did have something to do with it. I'll go ahead and tell you. The top of this fraction is odd. That means eventually I was going to have to use an odd root to cancel it. Odd roots never create pluses and minuses. The top of this one is an even number, which means eventually I was going to have to use an even root to cancel it. Even roots, canceling even exponents, cause plus or minus. So from the get-go, I have trained myself to look at the top number of an exponent and ask myself, is this going to get a plus or minus or not at the end? This one I would instantly go, nope, that's going to take a third root. I don't have to worry. Yup, that's going to take a square root, plus or minus. For example, if I wrote, I'm just going to make something up, negative 7x to the 14 15ths plus 1 equals 8. I mean, I am just going ham here. I would look at that and go, there's going to be a plus or minus in the answer, because the top of that exponent was an even number. The moment the top of the exponent is an even number, there's going to be a plus or minus in that question. Okay? You guys good with that? All right. I don't even know if this can be solved. I just was making crap up. Okay? I'm sure it's not a pretty answer. It probably has answers, but they'd be ugly. Actually, this is an impossible question. It has no answers. Even if you graphed it, they never touch each other. But you don't need to know that. If I erase the minus sign in front of the 7, it works. But don't worry about it. The point is, good Lord. The point is, I know there's going to be a plus or minus in the answer. That's what I was just trying to get at. Oh. Actually, the answer is plus or minus 1. I didn't mean for that to happen, but it does have pretty answers, plus or minus 1. You don't need to know that. Okay. What are we going to do first? We're going to subtract the 4. Reason why? We know we want that square root to go away, but you can't cancel a square root symbol until it's the only object on that side of the equal sign. So first thing we're going to do is move that 4 over. All right. Now what? What happened? We're going to cancel the square root. And how? Square both sides. Yep. Remember, x minus 4 squared does not mean x squared minus 16. It means x minus 4 times x minus 4. I'll actually write that out. I'm not going to show all the foiling steps, but I will write out that it's x minus 4 times x minus 4. Because at this point, I'm hoping that my students can FOIL. Out of curiosity, Maddie, did they call it FOIL up north? Okay, just making sure because it's done differently in different places. I just wanted to make sure. So yeah, you would just do x to -4 to x, -4 to -4. The point is you're going to get 2x plus 7 equals x squared minus 8x plus 16. I have x's with squares and x's without squares. How do I solve this? Well, yes, you said it a little bit backwards, but yeah. What Lewis was saying was we need to get all of this stuff to the left, and because we have x's and x squareds, factoring is our thing. We're going to have to move these two this way and then factor. Subtract 2x, subtract 7, subtract 2x, subtract 7. 0 equals x squared minus 10x plus 9. Again, this is the easy type of factoring where there's no number in front of x squared. Woohoo! That means we don't have to worry about the over a Lizzie method step. We can just say what two numbers multiply to positive 9 that add to negative 10. Catherine's saying it, but she's very quiet. What did you say? Negative 9 and negative 1. Those two numbers do multiply to positive 9 and add to negative 10. That means we get two solutions, and you seeing what's happening over here, you must be careful because this was a square root equation that had x's in the root and x's out of the root, which means extraneous solutions are very, very probable. Not even possible, probable. So we get two solutions. The solutions are what makes the inside equal 0. So 9 minus 9 is 0, so x equals 9, and 1 minus 1 equals 0, so x equals 1. Yeah, what's up? What do you mean a special? You mean if you get that there's an extraneous solution? X squared minus 9? Yeah. You would just factor that. X plus 3 times x minus 3. If it's a square minus a square, you're happy because it factors easily. But yeah, no, you don't have to identify it as a special case or anything. You just go ahead and factor it. So two solutions, we have to make sure they both work. So we're going to plug them in and see what happens. Let's start with the 9 because I wrote that first. Remember, I'm putting a 9 here and a 9 here. So I need this math over here to equal 9. Okay? 2 times 9 is 18. 18 plus 7 is 25. Square root of 25 is 5. 5 plus 4 is 9. 9 works. Now let's plug in the 1. Remember, I'm plugging in a 1 here and a 1 here. So this left side needs to equal 1 in order for this to work. 2 times 1 is 2. 2 plus 7 is 9. Square root of 9 is 3. 3 plus 4 is not 1. So this answer fails. So let me reiterate some facts about real solutions and extraneous solutions. It does not matter if the solution is positive or negative. That is unimportant. You see, you just saw a positive answer fail. That doesn't matter. What does matter is that when you plug it in, it's actually going to stay true. So Lewis asked, will 1 always fail? No. Is it likely that 1 fails? Very likely. Sorry, my phone's vibrating very loud because of where I have it setting. Very likely that 1 will fail, but it's not a guarantee. Remember when I was showing you the graphs yesterday? the square root graph looks something like, and it doesn't matter if it points right or points left, but it looks something like a shooting star, where it has a beginning and no end. And then if you run a straight line through it, you get an answer. One answer, not two. But could you get two? Absolutely. Because I'll use the same shooting star, but I'll change colors. My line could have done this. So that one hits it twice, right? Is it possible to get zero solutions? Absolutely. My line could do this. And that one would have zero solutions. So if you check and you get answers and you check them and neither one of them works, then you would just write no solutions. So it's 100% positive to have two answers, one answer, no answers, and that's why we check. Okay? All righty.